Okay, I'll change up the numbers a bit because I don't know if these ones are randomized, so obviously can't give out the right answers. Let's say n is 27, and then they're using pi, which I think is terrible notation. Oh, so let's change that to 28, and then this, let's say, is 0.25. The standard error they're talking about is for a population proportion. We were doing means. Add up all the numbers, divide by how many there are. That's the mean. A proportion is count up all the people that voted yes and divide by the total number of people that voted. So 11 out of 20 people voted yes. That's a proportion. So it's a different type of number. So that means we need a different formula for the standard error. So it's not too bad. Using their notation, this is what you would plug into the formula. So for my problem, I would plug in for pi, which is a crazy choice. I don't know why the textbook does that. 0.25 goes in for pi. And then look, 1 minus 0.25, you could do that and then write out your steps, but that's going to be 0.75. So I've got 0.25, and then it's times 0.75. And then I need to divide that by 28, according to the formula. And then once I've done that, I'm going to take the square root. So 0.81818. That's what goes into the calculation here. 0.818. Sorry, 0.0818. 4 decimal places, so there we go. That one rounds down. Okay, and then normality. There's a criteria that we have for normality is that n times p times 1 minus. Oh, sorry, I use p because that's how most textbooks do it. But n times. Oops, messed everything up. This has to be greater than 10, and then this also has to hold n times 1 minus that proportion needs to be greater than 10. So you got to do both of those, and both of them have to be true for normality. So if I do 27 times 0.35, that's 9.45. So that's not greater than 10. There's no point of even checking this one because it failed the normality check. So we'd say no here. Let me do another. Let's say n, actually the same one. Let's say n was actually 35. When I check the normality assumption, I do 35 times 0.35. That's 12.25. So that checks off with this one. I need to make sure it also holds over here. So if I do 35 times 1 minus 0.35, I'm using 0.25. 1 minus, that would be 0.75. That's also greater than 10. So this would be yes if the sample size is that big. So both of those formulas have to be true. You have to be able to plug in your numbers and get something greater than 10 here, plug in your numbers and get something greater than 10 here.